Here's another problem we want to solve. It's the square root of 3 sine x secant x equals 2 sine x. So the first step, if you look at an equation, you want to see, can you set it equal to 0, and maybe we can do some factoring here. So let's set it equal to 0, just like in algebra, nothing new. Square root of 3 sine x secant x minus 2 sine x equals 0. And then you always look to see, can you factor? And here we can factor out a sine of x. That is your greatest common factor. So if we divide both terms by the sine of x, we're left with the square root of 3 secant x minus 2 equals 0. Okay, so this looks pretty good. Now we're gonna set each factor equal to 0. So we have the sine of x equals 0 and the square root secant x minus 2 equals 0. So the first one's pretty simple. When is the sine equal to 0? Now you also have to look that we're looking at solutions over the interval from 0 included to pi is a parenthesis that is not included. So be careful here, because a lot of students always want to give me an answer of 2 pi, which in this case would be wrong. So x, the sine of x equals 0 for the angle 0, and when else is it 0? It is also 0 at pi. So these are my two answers for the sine of x equals 0. Now we're going to the other side. We'll bring the 2 over first. Square root of 3 secant x equals 2, and then we divide by the square root of 3, and if we rationalize the denominator, we get 2 square root of 3 over 3. So when is the secant, or for which angle is the secant a positive square root of 2 square root of 3 over 3, and that of course is in quadrant 1. The secant is positive, and also in quadrant 4. So now you got to know your common angles of 30, 60, 45 degrees. 2 square root of 3 over 3 corresponds to pi over 6 secant. So x is here pi over 6 in quadrant 1, and in quadrant 4 the answer would be 2 square root of 3. Oh no, yeah, right, that is my argument. So the answer is 11 pi over 6 in quadrant 4. Here you go. So your angles 0, pi over 6, quadrant 2, then quadrant 1, then pi, and then 11 pi over 6 in quadrant 4.